Okay, so in today's notes, you're going to need your graphing calculator. It's going to be similar to what we did the day before yesterday, when I wasn't here again. But basically what you're going to do is we're going to look at some exponential regression and quadratic regression, and that's exactly how it sounds. You're going to look at data that looks like an exponential graph, and you're going to look at data that looks like a quadratic graph. So the first page has us start off with exponential regression. Just cross this off because we're going to use our calculator to look at the scatter plots, and so we don't have to graph them. You should never have to graph the scatter plot on a region. You might have to look at one and draw conclusions from that, but you shouldn't have to graph it. But before you type this in, I want you to remember what we talked about last time with the years. So remember, when we're dealing with years, we have to start from 0 and then count up. So it looks like this is going by 1. All right, so I'll go from 0 to 8, and then I can just enter those stores as is. So you're going to go to Stat Edit, clear your lists, and then you're going to type in 0, 1, 2, 3, 4, 5, 6, 8. So then when you get here, so the only thing that's different, so if you want to look at your scatter plot again, remember, all your diagnostics should be on from yesterday, but if you don't remember, so that shouldn't affect anything. If you press Zoom 9, and it looks like I have already something plotted there, I should probably exit that out. Okay. So if I go to Zoom 9, it'll give me the scatter plot, and if you look at it, it's starting to go up a curve like an exponential graph. So this data seems to have an exponential regression, exponential pattern. So it has to, does this data appear to have a linear association? No, because it is curved. Then it says, what type of a relationship does the data appear to have? Exponential. Because it increases at a non-steady rate. Okay, so that is the first page, and so you can always use this to kind of tell where your data is going toward. Are you leaning more towards linear, exponential, quadratic, etc.? So if you flip to the next page, so to determine the equation of line of best fit, we can make an equation for the line of best fit, except it's not going to be a line, it's going to be a curve. It's going to be an exponential function. So you can do kind of the same thing we did last time. So you're going to do stat calc, but instead of linear regression, you're going to go all the way down to option 0, which is EXP regression. You see it, EXP regression. If you press enter, just press enter a couple times, make sure the lists are correctly stored, and then you follow this equation, y equals a times b to the x, and we know that from our exponential unit anyway. So all you got to do is fill in the numbers. It wants us to round to the nearest hundredth. So this equation is going to be 16.81 times 1.59 to the x power, round all values to the nearest hundredth. Then it says use your equation to predict the number of stores in 2000. So 2000 is how many years away from 1986? So you can do, that's 14 years, so you would actually plug in the number 14 for x, since that's how we did our values there. Okay. So to see how close your line is to the data, you can graph this line, or this curve, onto the graph. So if you go to y equals, you can type in this equation right here, 16.81 in parentheses 1.59 to the x power. And if you press Zoom 9 again, it should take you to the graph. And if you look, that line of best fit is like almost perfect to that line, or to the data. If you want to look at the correlation coefficient, just like in the linear model, you're going to look at that R value, and it says 0.99, so that's a pretty good fit. So the R value will just say that's, again, the correlation coefficient. So it's just telling us how good of a line is that for our data. The closer it is to 1 or -1, the better. That's 0.996, which is very high. It's very close to 1. So that means that this model is perfect for our data. All right, if you want to flip the page, so take a minute. So if you look at this data, take a minute and plot it in your graph. And I wanted to talk specifically about C and E. So take a minute, put this data into your calculator. Zero, 2, 4. All right, so then it says write the exponential equation, and you can do that. So if it wants you to do the exponential equation, you're going to go to Stat Calc and then Exponent Regression, which is option number 0. Okay, and so let's drop down to question E or C here. It says to look at the R value. So if you look, the R value for exponential is negative 0.993. And then it tells you to write the linear regression for this data. So if you go to Stat Calc, you're going to go to linear regression. And you want to look at the R value for that. So that in part E, it wants you to look at the R value for the linear model. So if you go to linreg, you should see your equation, which will answer part D. And then in part E, the R value, again, is negative 0.993. You round. I think this one's 4. You might have rounded wrong. And if you notice, those are exactly the same. So you might be asking, all right, then what model do we use? Is exponential better or is linear better? So that's where you can look at the plot. And if you look at it, it kind of, it could be going exponential, could be going linear. This might be a spot where we have to, we need more data to make a valid conclusion of what model is better. So because we only have so many data points, we can't really tell what is a better model, exponential or linear, and you might run into that. That's fine. Okay. I think this one is slightly higher. If I go back, let me go to Stat Calc and then 0. I think I might have rounded wrong. 99. Yeah, this is 994. So this is exponential is a slightly better model. But all the other questions you should be able to answer by yourself. And then if you go to the quadratic regression, the only thing that's different about this data and this data we've been working with is when you go to calculate it, you're going to want to use quadrag, which is option number 5 in your calculator. So whenever it says a quadratic function to give you a quadratic function for the data, you can look at that. The only other thing I want to tell you is quadratic is the only one where the correlation coefficient is the R squared value. It doesn't, if you look, it doesn't give you the R value. It just gives you the R squared value. So that is actually your correlation coefficient for any quadratic. So linear is R value, exponential is R value, quadratic is R squared value. So don't freak out if you don't see the R value for the quadratic. It works the same as all the other ones. So fill in the rest of the packet. If you have any questions, you can go ahead and ask us up. And talk to me on Monday. Thank you.